All right, good afternoon, everyone. Welcome for the February edition of the VLab Forum. This is Steve Smith, Director of the VLab, and I'm joined by our production manager, John Chattel, here in the VLab Forum studios in downtown Silver Spring, Maryland, in the shadow of the giant acorn. Today, we are privileged to have a talk on the Weather Archive and Visualization Environment, aka WAVE demo, to be presented by Travis Wilson of WFO Phoenix and Bill Rasch of WFO Sacramento. Travis is formerly of another WFO. He's just recently joined Phoenix. The WAVE was brought to our attention recently. They joined the VLab and have a VLab community that they're using to great benefit in fostering the sharing of this software and the use of the software and the development of the software. We had them present at the monthly owners VLab community and project owners meeting, and we're very, very impressed with what they had to show. And last week they presented at the STI annual operating plan meeting, and also to a very enthralled audience, and got a lot of praise for that. So we had booked them for this, and the snowball is growing, I guess, so to speak. I hope you will be impressed with what they have to show. Reminding everyone, the format of these forums is about 30 minutes or so of presentation by our speakers. They're going to do a demo as well. And then the remainder of the hour is devoted to question and answers. So we ask that you, unless it's a really critical clarification question, to sort of hold your questions until that 30-minute Q&A. When we do get to the Q&A, please use the raise your hand feature of the GoToMeeting or the chat to ask a question. And if you use the raise your hand, John Chattel will unmute you so you can pose your question directly to the speakers. Also, a reminder that this will be recorded and uploaded to the VLab Forum website shortly after the conclusion of this afternoon's session. So without further ado, I'm going to hand it over to Bill and Travis.
Thank you very much. Thanks for the kind words. Thanks for this opportunity. So Travis is the main developer of WAVE, and Travis, we hired Travis as an intern here. He started his work here in Sacramento, and just a week or two, I just updated this slide. I finally had to put Phoenix in there. I had to take Sacramento off. I realized he's gone now. So Travis is in Phoenix. I'm happy for Travis. He got a promotion. But this project started here in Sacramento. It's been really fun, and I'm gonna do as quick as an overview as I can, get into some examples of what it can do, and then Travis will give a live demo for about 15 minutes, and then hopefully it'll be about a half hour by the time we do all that. So if you get a copy of this presentation we made for the AOP meeting, we wanted to demonstrate how WAVE is being used by the field. So I sent out a request on all the VLab people, which I think we're up to like 230 or something people like that right now, and asked for people if they wouldn't mind giving little video testimonials, and we got a lot of people that responded back, and we just wanted to put that into a video to demonstrate how it's being used. So come back later and look at the video. It's 6 minutes long, so to save time, I'm not going to show that right now. So the next slide is basically what is WAVE, and I could talk a long time about this. We'll try to be short and concise, but basically it's, like it says, a multi-purpose system that effectively manages and visualizes data. So it's accessible via a web browser, and it is an archiving system. Depending on how big the drive is that it's running on, it depends on how much we can archive. Obviously, the bigger more space we have, the more we can archive. It is currently hosted at Western Region headquarters. We're really thankful for them doing that for us. It's not on the fastest of systems, so keep that in mind sometimes when you're using it. Travis has done some amazing work designing this, and I don't know if I emphasize that enough, that Travis has done some amazing work with this. And it's only, the way he built it, it doesn't really need a lot of memory. It builds images on the server side, and it's really CPU intensive. We only have 2 CPUs right now, but we haven't really seen a degradation in quality. But as we get more and more users, we're hoping we can eventually get on a system that has a little bit more oomph in it. Also, we're a little bit limited on space right now, so we're having to kind of delete data here and there until we get a bigger, faster system, which Western Region Headquarters is working on. It's not that complicated, the scripting. I mean, Travis has done such an amazing job, but if you're curious, it uses a program called GRADS, which generates the ping images, and then Travis does a really cool compression technique on it to send those images across the web to whoever is using it. Also uses Bash scripts and PHP scripts. The data, it gets into Wave basically from AWIP's SBN, but the cool part about Wave, we think anyway, is we can basically gobble up any data that's there. If it's in GRIB2 format, it's really easy. So we can go out and hit FTP sites too and download data and get everything all in one place. So why is there a need for Wave? Personally, for me, this was my dream project because as a SUE, to be an effective SUE and to make effective training, you have to collect a lot of data, and that may be for something as simple as a case study. One of my favorite ways to help train the staff is throw together quick training content, maybe a week or 2 after an event happens. And I don't really need every 25 millibars of every model to do that. I really only need a few key fields and throw things together. And before Wave or the current system we have, it's really kind of hard to do that. You might have to have certain technical skills. You have to go to different websites. Everything looks different. It's not time synced. You don't always have observational data with that data. So that was kind of the need for me. But also, we wanted to make it so that this could do more than just help the SUEs. We wanted this to also turn around all that content, all this wonderful content we have as a weather service, and also give it a chance so the field could use it, and people that are maybe out in the field like IMETs or people that are emergency operations centers, taking all this data we have and this complex data and then basically spit out clear, concise, pretty images of that information that's great for DSS, where customers can easily understand things and we can get our messaging to get people to take action based on a clear, concise image of all this wonderful data that we have in the weather service. So basically, a tool that does all the things on the screen there, support operations, O2R, R2O, increase efficiency, and then also a consistent IDSS content source. So we think that Wave does that. I mean, it's helping me anyway. It does a great job of data management. It does go out and get all these data sets and puts it in one place, has the same look and feel, model data sets and observational data sets. It can really be a great tool. If I had a model and I wanted to get feedback from the field, personally, I would want to get my data on something like the Wave. It gets it to everybody. They can compare it with other data sets, and they can put it right next to observational data sets and quickly and very, very efficiently throw together images or something to get back to the researchers to show where something might have happened or something didn't happen. On the next slide, though, I'll show you the data sets we have, too. And also, some of the feedback we get, it's so easy to use. Travis and I take care of all the logistics and all the technical stuff on our side, so you don't have to worry about it. So it's a very intuitive interface and very easy to use. And this was developed mainly as a SUE tool, so I've been putting this bonus on my slides, but we're seeing, I don't know, maybe it's just as much use, if not more, from the field that people are using this for their DSS content. They're sharing it with their core partners. They're sharing it on social media. It's just a great way to communicate complex weather information. So here's the data sets that we currently...
Okay.
Wow.
It's on the web
my phone thought I was talking to it. That was funny. So here's the archive data that we currently have. We have basically all the operational data sets, and we do have a handful of experimental data sets, which is really fun to put those things side by side and easily compare them. We have a bunch of observational data. We have national centers, and we also have put a lot of the data in respect to the NOAA Atlas 14 ARI, average return interval information. We'll have a couple examples of that. And just over the last 2 days, we were able to start putting in data sets for the Pacific region and Alaska region. It's not operational yet, but proof of concept, we have some of that data currently flowing in, but it's not operational yet. So what more could we do? We think we could do a lot more if we had the time and the resources. And the number one thing that I would like to do if I were in charge, I would love to expand kind of the axis of WAVE. Our IMET was just dispatched up to a pretty high-profile situation up by Oroville here, and he asked me 2 or 3 times if he could have access to the WAVE while he was there. It would have been really great for him to look at this kind of data and then use it in his briefings. I've heard that kind of feedback from many people, and that kind of highlights one of the cool things about the way Travis has designed this, that it's so light on its feet that all you need is a web browser. You're not going to be stealing all the bandwidth from wherever you are. It's very light. It hosts, quote unquote, the good stuff. It doesn't have, like I said, every 25 millibars of every model. We get what we think is the most useful information on there, and it's easily accessible. We really want to expand our data sets, and we want to get things like ensemble data, the NCARS high-res ensemble data. We want to get WARN-ON forecast data. We want to get anomaly and analog data. We want to get more radar data. It could gobble in GOES 16 as well. And it also has the ability to get non-traditional data sets, things like the FEMA risk data. Just another example, the Forest Service, they have things called a BEAR team. And these BEAR teams will put out flash flood guidance. But it's in a form that's very difficult to get into AWIPS or anything like that. So WAVE can also, I'll use that term again, gobble that stuff up and display it. It's really great functionality for that. And if you ever talk to Travis, he has lots of plans in his head. He thinks he can take this thing to a whole new level. Things like scrolling the zoom and really improve it. So functionality, we would definitely like to build more of that. And also, we do have kind of a poor man's verification ability right now, but we'd like to make that more robust. So real quick, I'm going to go through these examples pretty quickly so Travis will have time to do his live demo. But here's some examples. Travis uses something called adaptive resolution on WAVE, which is something really useful for the speed of it. When you start up WAVE, it's the CONUS view, and if you were to pull up the MRMS, it doesn't have it at the highest resolution to save time and speed. But as you left-click, drag, and left-click and zoom into an area, then it increases the resolution to be close to the native resolution or the native resolution. So it's a technique to save on speed. And this is just a simple example of MRMS reflectivity. Here's a really fun thing, and this is one of the main reasons that I needed a system or wanted a system like this. On the top, you'll see we have top left some reflectivity, top right MRMS rotation tracks, which is archived back as far as we can have space to do it. And then on the bottom, you actually have the HER and the HER experimental right there side by side. You can verify what happened, compare the two really quickly and easily. Just another MRMS example showing that you can have mesh tracks, rotation tracks. Basically, not everything that the MRMS has right now. We do filter out some of the stuff. Again, we're trying to save space, be efficient, be quick, and filter out the data that we think is important. And we can always tweak that, of course. Here's an example of how we're using the Atlas ARI values. In the bottom left is the HER experimental's QPF forecast, and then putting that in a perspective of giving it some kind of a climatological context. So you may look at a QPF amount, or you may look at a QPE amount, but does it, climatologically, how significant it is? And that's where the Atlas ARI value can be of value. And that's not only a SU tool, but that's also a DSS tool. If you're at an EOC and you want to demonstrate the climatological significance of something coming in, grab their attention, put it in some kind of terms they might understand. If you say something like this is a 30-year return interval or 30-year event, that might get their attention, and this gives us the ability to do that. So that on that screen, we were putting it as a percentage of a 1-year ARI in the bottom left. In this one, the other way you can view it in WAVE is it actually plots the return interval itself. So it will plot it out if it's a 5-year, 10-year, 15-year, 20-year. Here's an example. This is a pretty nifty thing that we built into it. This, in the bottom right, is what we call our initialization or verification type mentality. We save off the 0-hour forecast of the NAM and the RAP, so you can then, it kind of acts as an answer key to show you what happened. So this will automatically time sync up with whatever you have, and we do have those initializations saved off for many fields. So in this case, I'm comparing the GFS 20, the GFS experimental, and the EC, and then putting, quote unquote, the answer key in the bottom right there, so you can look back and see what model may have performed differently or better. It does also sample. This is a really handy tool lately for people that are trying to get feedback to the IRMA people. You can see in the top left is the IRMA, the HER, and HER experimental 2-meter temperature, and then you can sample the data and look at the difference and maybe get back that feedback back to the developers. We just started, here's an example of QPF, and of course, and QPE. So with MRMS, you have some really nice QPE options. This is just showing the different options. Out in the west here, we like the mountain mapper option, and in the top right there is radar with gauge correction. This is one of the tools I really enjoy as a SU2. It's crazy how easy it is to download NAR data and go back to 1973 if we needed. This is an example of a historic wind event we had in Northern California. So this is a great analog type tool for forecasters. I can download significant events, then they can pull that up, look at it, and maybe compare it to the current forecast. Or they can also use this in DSS too, so they can mention things like this storm looks just like the big storm back in '65 or something like that. So it's very useful. We are pulling in National Center's data. This is WPC's PWPF, probability of 1, 2, 4, and 8 inches. That is not operational yet. It's something we're continuing to finalize, but it's in there. We just need more time to get it working. And we are pulling in WPC's QPF as well, and NDFD's, a few fields of NDFD. You can see in that image there in the bottom right is the NDFD compared to some different data sets. And just a real quick example of NDFD. On the left there is accumulating precip for a storm coming in for us this weekend, and on the right is how you can use it maybe for max temperatures. I'm right at about 15 minutes, and I'm almost done here. But these are examples of how SUs have used it. I'm going to quickly go through and show you how the field's been using this. Phoenix, Boise, Hanford. These are from Twitter feeds. Boston, Wakefield, Gaylord, Central Region, Bay Area. On the right is a partner email from Reno, LA, Columbia, Portland, Milwaukee, Memphis, Birmingham, Flagstaff, Caribou, Billings, Missoula, Great Falls. We do have about 250 members on VLab. It's getting up there, so we're really happy to see that people seem to be embracing it and using it. It is already being used by SUs and WFOs. We're up to about 100 unique users per day. So summing it up before I pass it on to Travis, I think what we have here is a functioning prototype that might be filling a large need. It greatly increases the efficiency of SUs. It helps the field, and it helps the research field as well. So one last thing I want to say in this slide is that this is not a WES replacement. This is rather an example of how the future WES, there's some features that the future WES or other systems the Weather Service designs might have. And that's why we were really glad to have our talk at the AOP meeting to demonstrate this, and it seems to be getting accepted. So we'll see where it goes from there. Here's the folks that have been helping us. I'm already a little over here, so I'm going to go and hand it over to Travis.
All right, thanks, Bill. Can everybody hear me?
Yeah, Travis, we can hear you loud and clear.
Okay. And can you see my screen? You see Wave up there?
Yes.
Okay. So, as Bill mentioned, I was an intern in Sacramento. Bill and Dan both graciously hired me and took a chance. I've moved on since to Phoenix. I've been here for about 2 weeks just getting settled in. Wave was a project Bill just gave to me as kind of a challenge to see if we could do it. Dream project. We built it in Sacramento. It was only supposed to be for Sacramento, but somehow we turned it into the whole entire CONUS, and we've had a really good time building it. So just quickly on the demo, when you start up Wave, it always defaults to the current day. But what I'm going to do and show you today, I'm actually going to show you some archive data. But you can pretty much just go up here and set your year, month, and your day, and you press set, and just like that, you are back in time, and you can start looking at old data. When I developed Wave, I did it on different monitors with different resolutions, and so from the get-go, I built this little size scroll bar here, where you're able to adjust the size so it would fit your screen, basically. Another thing that we've just updated with Wave, we've separated all the layers that it plots, so you're actually able to change the opacity of the layer that you're looking at. So you can use the plus and minus key on your keyboards like I'm doing now and toggle it just kind of like AWIPs. And we've also put this readout function here where you can actually sample the data points. You can change it to really small or really big if you're giving a briefing, or essentially just turn off the readout, which I will probably do for most of this presentation. And so I wanted to start off just by looking at an event. By changing the model, you just click this data set button and you could select a variety of different data sets, observations, analysis. But I'm going to start with the GFS. And with this variable drop-down, you're able to select different fields. So we have a variety of them. We are always adding more. But for now, I'm going to select 6-hour precip, and I'm just going to build it for the entire CONUS. And so what you can see, when I press the submit button, it essentially sends a request to the server. The server builds the images, it builds several images in a matter of seconds, and it sends it back to the user as compressed PNG images. And then on the front end, I layer all the different layers, such as the map and the title and the actual shaded field all together. And this is what you get on the front end. From the get-go, I wanted Wave to have multiple panels and be able to compare things. So if you press this window button, you just duplicate the window that you had in the first panel. And each panel is separate, and you can display whatever you want. It's independent of the other one. You could change different models and different fields. So if I select, let's go with vorticity and heights, 500 millibars, I press the submit button, takes the job to the server, and eventually it'll send it back to me, and that's what you get on the front end. And currently right now we have a total of 4 panels. I don't plan on expanding that right now. I think we're pretty good with 4-panel layout. But again, you can display whatever you want on each of the panels. So on that third panel, I just put precipitable water. And if I was giving a briefing to my WFO, I could sample all the values and say, oh, we have precipitable water values around 2 inches and a ½ inch of rain in Gulf of Mexico. Okay. And I think Bill kind of mentioned it in his presentation too, that we're able to compare forecasts to an analysis. So if you go to the data sets and select, say, the NAM analysis, you're actually going to be looking at the 0-hour fields of the NAM. And so if I select heights or vorticity, you can see we have a variety of different fields for the analysis. And select 500 millibars, go to that real quick and press submit. Eventually what we get back is the analysis. So in the top right, I have the GFS forecast, and the bottom right is the NAM analysis. And you can see at 132 hours, which the hours are shown down here in the bottom, the 32-hour forecast actually lines up pretty well with what the analysis and the forecast said. If I go beyond this, you'll see that the analysis will drop out. It's because we don't have an analysis yet. This is actually the future now, and this is the past. So Bill kind of touched on this in his presentation, but return intervals are a pretty powerful thing, especially when looking at events. So what I'm going to do is look at an event that we just had in California, and I'm going to load the 24-hour precipitation for the GFS. And a little different from AWIPS, you can actually select, 6, 12 hour, 24, all the way up to 72-hour precipitation, and you're actually able to compare these with return intervals. So if I step through time, there was one event here where the GFS was actually forecasting around 10 inches of rain. And so if you know this area, this is right around the Oroville Dam, where it was making national news. You had problems with the spillway. And if the forecaster we sent out to Oroville Dam had access to this, he could actually look up return intervals. How normal is this? And I think you could probably guess that 10 inches of rain in a 24-hour period is not normal. So if I pull up return intervals for the GFS 20 during this time period, you'll see when it eventually gets loaded that it is not normal. So one thing here with Wave is with a live demo, if other people are using it, it does slow me down. We only have 2 CPUs right now, and really anybody in the Weather Service could be using this Wave right now. We have about 100 users a day, and so you'll notice various performance just because of the system that we have. But going back to this, you'll see we have a 100-year return interval. So in this particular location, 6.5 inches of rain really only happens once every 100 years. So you could use this to basically educate yourself on the climatological significance of these events. And another thing that we've added in is being able to do a deprog DT. So actually I can compare the next run of the GFS to the past run, and everything time syncs together. So I'm just selecting 24-hour precipitation, and I'm going to build that in the bottom left for the GFS 20 again. So in the top left, you have the GFS 20 at 0Z, and the bottom right will be the GFS 20 at 12Z. And you can see that really in a matter of 12 hours time span, the GFS cut its precipitation in half, and the return interval, if I plotted that real quickly, it would also reflect that. So it's really nice to do a deprog DT, and again, everything time syncs. Okay. So now I'm going to kind of move on to what we've added recently, and I'm going to load up some MRMS data and talk about the layers and what you can do and how you can message with Wave. And so with the MRMS, if you have been using Wave in the past, it was a little flaky. I believe I fixed that now. It seems that all the data is being ingested. But you can select different things like reflectivity, precip type, rotational tracks. But I'm just going to select the precip type for California and make sure I'm on the right day. So I wanted to select the 20th. And here we go. But essentially, as it builds these images, I'm going to be demoing what we have added in terms of layers for the MRMS. And I can tell already that Wave is slowing down significantly in terms of performance. So down here, while this loads, and again, it normally doesn't take this long, you can add different layers. Since this new update, we have separated all the layers, so you can now plot states, counties, borders, and thicknesses. So if I turn off states, you essentially just turn it off from all your panels that you have plotted up there. And you can turn on counties. You can actually change the color of your border if you wanted to. So I could change it to white if need be. And again, it sends a job to the server and it shoots it back pretty quickly. You can change the thicknesses of your border if you wanted a really thick border, or if you wanted it thin, how we had it originally. And I really built all this for messaging. We're always encouraged to create clear, concise messages at the NWS Sacramento, and it always took me a while to put together a nice radar loop, or maybe model reflectivity of the HER. And now I can do it in seconds with Wave, and I can still make it highly customizable. And so there you can see I can add terrain if I wanted to, and it makes beautiful images very quickly. Change the ocean color if you want to do something a little more natural, not black. But you can also add roads. Another big thing that we've added is being able to change the banner. So if I like this image and I want to communicate it to my partners or just to the general public, I don't want to be using this banner up here with Zulu time, right? Only us scientists, really understand Zulu. So there's this drop down where if you change to the public banner, you get local time, which is nice for anybody who's viewing the image. Watches and warnings you can add cities, which is pretty nice. And then I'll talk about the mask momentarily. But let's say we like this image. We've added this GIF maker function at the very bottom of Wave. And if you press this button, you can actually just select which time periods you want. Let's say I only want to tweet out hours 8 to 9. You press the make button, you can adjust your frame delay, and it basically sends a job to the server. The more layers you have, the longer it takes, and it sends this job back to you, hopefully fairly quickly. And then essentially you got a GIF that you can tweet out, or you got an MP4 that you can post to Facebook. Okay, so here it is. And then I would simply just take this and tweet it out to Facebook. This happens to be MRMS reflectivity, but you can do this with any field you want for any model. Okay, so let me turn off some stuff. I wanted to show you real quickly before I ended NDFD. So we've added the basic variables to Wave. And again, this is for social media and messaging. So if I do the max temperatures for Stowe and just press submit, you'll get the NDFD max temperatures for our area. I should say really my past area now, not my current area. And again, I apologize for the delay. It's always difficult doing live demos because you test it and everything goes well, and then finally when you start doing the demo, it slows way down. So this kind of just speaks to our need of resources on this project. So I have 2 CPUs for the entire weather service, and it makes it difficult to program something. But here we go. I got NDFD. One thing I did want to show that is you can increase the city density. Let's say I wanted to tweet out the high temperatures for tomorrow or something like that. I can change the density. I can even change the size of the font. One request we've been getting is the color of the font. That will be added soon enough. And a lot of times we don't like this excess layer of temperatures that overlays over the ocean. So I have this mask option where you can turn it on for individual states, or let's just go to the United States, and it'll make a nice clean cut, and it will only mask the United States. And so this is great, but this is difficult to read because it has no values on it. And the very last thing I wanted to show you is this little button down here. It's called Get Point Values. If you click this, it will say this will create point values using medium density and 16-point font. That's just basically referring to the fact that it's going to submit a job to the server. It's going to get point values for all these cities, which is the medium density city, and it's going to plot it in that font size. And so normally this takes just a few seconds, and you'll see you now have point values that you can basically tweet out as an animated GIF. You can tweet out a single frame. You can add layers to make it look the way you want, and basically communicate a message effectively. One thing I do want to note, you'll see that the layer of the text here, see San Francisco only has an 8. It is masked right now, and the lines, the county lines, overwrite the temperature values. This is a known bug. This is something high on my list that I'm going to fix very soon. It's just if you need to tweet out exact temperatures, point values, I would recommend using the old version, which you can just click here and get to it. But it's just a work in progress, and I think that pretty much sums up my Wave demo for now.
All right. Thank you very much, Travis and Bill. Very impressive. It just in every aspect, and how quickly you were able to pull this together, the functionality that you have, put in place, and and how people are using it. I do encourage people to go see this, the YouTube video of the testimonials. It is quite impressive. So now we're going to turn to the Q&A section of the forum, and we're going to open up. So if you raise your hand, we will unmute you. We got our first person, Jeff Wallstreicher. Jeff, go ahead.
Hey, Bill and Travis, thanks for the demo. Question, you mentioned that depending on the scale you're displaying, you do some data thinning. And I'm wondering how that impacts the data sampling tool, and how a forecaster can know what scale they're actually sampling on, because that can have real implications if they're doing some assessment like HER or RTMA IRMA assessment, if you're not actually looking at native resolution.
Right. So when you sample with this point, that's always at the same resolution. So this is certainly not the same resolution as the PNG that's in the background. And the reason that is because it requires a massive file to be sent over the internet. If there was some good compression that I can compress an array for the sample out that I could send to the front-end user, I would have, but you can see the resolution as I move my my cursor over. You see how often it updates, and so yeah, that is a problem, but it is pulling the native resolution of the grid at that point. It's just not pulling every point.
Can I make a comment about that too? One of the main reasons this thing was developed wasn't necessarily for that high fidelity, really in-depth research. That's still probably something that Wes is going to do. I mean, we can improve on that, but it wasn't really built to be doing really high fidelity type research.
Right, but you had mentioned that it was starting to be used for some assessment activities of experimental models and and evaluation purposes. So
right, I think it serves that purpose pretty well. I think, but yeah, it could be a little better in that area you're talking about, I think.
Yeah, again, because if you're dropping out sample points and the issue is, it missed the valley, it's not representing the valley quite right, or in terrain, no, it's you don't know if it is or it isn't, because you're not sampling every grid point. I certainly understand why you did it, but that's just a very key awareness.
How often do you think that happens, Travis, or how do you think it affects it? Do you have any kind of like sense of that, Travis?
No, it was just the closer you zoom in, the better sample you'll have. I mean, if I'm sampling up at this level, you're totally going to miss valleys. But if you're zoomed into, Sacramento, you're not going to miss the valley at all.
Yeah, it would be
a matter of zooming and taking advantage of that adaptive resolution. Yeah.
Right. It would almost be nice if there was a way off in the corner, and maybe outside the actual graphic window. You can almost have a 3 means you're getting every third grid point. It's almost like the old Gempack switch, so that so it's just for those that are doing that kind of work. Okay, what did this generate it at? Generated it at a native resolution or.
Yeah, you know what? Another thing that we had considered about doing was just turning off any of that feature at all. And just if you're investigating at that level, you would just have to wait for the image to be created a little bit longer. So we could, in theory, we could just turn off that adaptive resolution part, and then if you're really into that high fidelity type interest, it would just take you a little bit longer to get the image. That would be the only difference. So that's something to think about for sure.
Yeah, I mean, I certainly understand the motivation. It's just kind of that cross application. And a user awareness level that if they're, that they may not be thinking about the adaptive resolution when they're doing something, thinking it may be a high resolution. And so at what point am I zoomed in enough to be getting 2.5 kilometer sampling or.
Yeah, it's a good feedback. Thank you.
Okay, thanks, Jeff. And let's go to Brandon Smith. Got a question. Brandon?
Okay. Hi, everybody. Yeah, to echo the first sentiment by Jeff, this is really neat. I am, guys who don't know, I'm a Weather Service meteorologist, but permanently stationed at the FAA Command Center in Virginia. So sort of like a CWSU, we're a permanently deployed IMET, if you will. So living in almost a pure DSS world. So I really think this is something that could literally change the way we do our work here, because right now, as you know, Weather Service graphics for DSS vary widely, and some of them just aren't that great, and these are really nice looking. So rather than ask a ton of questions about what can we get out of this, what's the easiest way? Like, I've got a list of things that I would need in order to use this every day, like shapefile backgrounds and things like that. Can I email you a list, or should we talk offline? What is the easiest way for me to tell you what we would need in order to make utility out of this on a daily basis?
I think right now the easiest way is just go to our VLab. It's linked from the bottom of the Wave webpage, or just go to VLab and search for Wave, and you can submit questions, comments, or features that you want.
Okay.
And so when you email it there, it goes to me, it goes to Bill, and it goes to actually a few other people who are helping us out with Wave. And so if there's a shapefile you want in there, I could easily just build a functionality where we can just populate these shapefiles and plot them, and so you get the right backgrounds that you want.
Yeah, perfect. Okay, and I'm either I have everything we already would need, or it should be pretty easy to get. Another question along the same lines is, do you have plans to add more elements to the existing models and possibly add even more models in the future, or is it kind of dependent on the server that you're running on?
No, we can easily add more elements, more models. The problem is right now is mostly time. I've been the main developer of this, and I just moved to Phoenix. I'm trying to get spun up here. I do this in my free time.
Gotcha.
If the Weather Service wanted me to develop this and add features, full time, I'm happy to do it. It's just a little slow on the development side, just because I'm always searching for the time to do it.
Sure thing. Okay. Well, like I say, I'll reiterate again. When I showed this to Bill, had sent me the link to this a few weeks ago, and we are probably more excited about this than just about anything we've got going right now because it's exactly what we need. So I'll be in touch then. But that's really my questions for now.
Well, thank you for those kind words. We appreciate it a lot.
Sure thing.
Thanks, Brandon. We're going to go to John Dumas now. John, you there?
Yeah, I'm here.
Go ahead.
The only reason that I didn't submit my part of a movie on how much we use this here is we were using it so much over the last couple of weeks with the atmospheric rivers. The forecasters like it to make the social media graphics. We can tweet out a real quick thing like they showed. And the WCM and I have just spent most of our morning doing post-event analysis using this tool. It was the first thing we reached for. So great job putting this together. I suppose all of the things that, like they said, the best way is to submit feedback to you via VLab. Is that what I'm hearing, rather than bothering you with emails on each individual item?
Yeah, I say that only because when you send an email through VLab, it goes to me and a lot of other people. If I'm off or there's some crazy weather and I can't get to it for a week or something, somebody else will get to it. So I still get it regardless. But you're always welcome to email me personally if you'd like to. But the best is probably through VLab.
Okay, so the answer I heard is to eliminate your time off. All right, great. The one question I do want to ask now, you put EC as one of the models that we can look at. Is there a limitation on what we're allowed to post of EC stuff? I know there's some sensitivity with us actually showing their data.
Yeah, as far as I know, I don't think we can post anything. That's not a question really I can answer. Bill, you can jump in if you know the answer.
And that's how I understand it too. It's not, you're not supposed to use it. So, I mean, we put it on there just for the Sioux part of it, but you just kind of use the same thought that you just don't share the EC. That's how I've always understood it. And I also may not be the right person to answer that, but that's the mentality I've always had. And thanks, John, for using it. And let me also just really quickly use this. Obviously, this is the VLab forum. The VLab has worked wonderful for us. If you have some, VLab has been really great, and it's functioning for us fantastically.
Good to hear. Thank you.
So I don't see any other questions at the moment. If you have a question, we have one from WFO Memphis. John, you want to read that one?
Yeah, it says, can you save the 4-panel layout for the next time you go into Wave and call up the same display?
Yeah, so I've been thinking about that, and it's something I wanted to implement actually before I left Sacramento. So I had 3 weeks of basically admin shifts to work on Wave, and it dwindled down to 1 just because of all the weather. But adding procedures where you could, save a 4-panel of this, whatever you want, that was on my list to do. I really don't know when that's going to get done. My one concern why I haven't implemented it earlier is, again, a CPU. That basically allows somebody to submit many different jobs with all the tabs they can open. And you can see how it can slow down with 2 CPUs for I don't know how many employees in the Weather Service. So it's on my radar. I just don't know when it's going to be implemented or how I should do that so it doesn't bog down the entire server.
All right. And now we've got another one. John, you want to read that?
Yeah, it's from Mike DeWeese, and he says, would love to see RFC Stage 4 QPE on this. Is that possible?
Say that again, the what?
The RFC Stage 4 QPE.
Oh, yeah, it's actually on Wave. That does come across on IRMA, and we are ingesting IRMA, but it's just it's on our short list. So yes, we want to see that too, and we also want to see the RFC's QPF. So those 2 data sets are on our very short list, and they're actually getting ingested into Wave. So once we get the plotting function going, you'll be able to go look back at it for a couple months at least so far that we've been archiving it. So yeah, I agree. That's a really important one, and the the answer is yes, Wave can do it, and we're close to doing it. It's just a matter of getting a little time to do it. If the weather would just settle down out here for us.
And Mike DeWeese replies through the chat, excellent. So,
okay, cool.
We've got a question from in the room here. Go ahead, Dennis.
Yes, is there some master menu where you could see all the possible fields and models that you could look at data from?
I have on the VLab page. I do have a table which I need to update, and it shows which data sets we have and how far back we have them archived. So I think that would help you. I do need to update it, and also it's a little fluid since we're still waiting for our larger system. We've been having to unfortunately delete data here and there, but let me update that, and there is something for that. And Travis is also showing a little monitor page we have too. But yeah, we have a list on the VLab page for that. I think it would help you.
Mark Laufelbein made this status page for us, which is really slick, so you can go in and see which data sets are there. The actual individual variables that you can plot for each data set, you actually, unfortunately, you have to just select the one you want, and then you can view the actual.
Oh, and if I'm sorry, if that's what you meant, I don't have a table of that, but I could do that. I could definitely break it down, model, and what variables we have. All I have right now is which models we have and how far back they go. But that's a great suggestion. I'll put it on the list.
So this is Steve Smith again. So Bill and Travis, it seems like one thing that would benefit in considering going forward and how you go forward is to kind of assess the different use cases that Wave is currently being applied to, in the sense that asking your users, you know, if you use the Wave, did you use it for IDSS? Did you use it for SUE? Did you use it for this thing? Because that would give a better idea of the type of operational implementation we need to consider. I know last week we were talking about some kind of potential solution that was not necessarily a gold standard implementation in IDP. But on the other hand, if it turns out that your main use case is IDSS, then maybe it does need to be, you know, sort of up all the time because people would be relying on it for that purpose. So I don't know if there's a way to do a survey or have people check a log box or something on use of Wave that you keep track of those statistics would be useful in assessing, you know, it's great that there are multiple users and multiple purposes, but we do need to kind of know what's the bread and butter, if there is.
Yeah, I agree. That's a great, and I've been struggling with that. I just don't know how to track the SUEs as easily as like just checking Twitter feeds and Facebook feeds. That's so much easier to track. That's a great suggestion, and you know what, we'll kick some ideas around. Maybe we'll include you. You can help us out how to figure that out. That's a great suggestion.
Okay, question in the room. We've got a question from Jim Calkins.
Yeah, this is Jim. I'm with Office of Central Processing, and I'm leading the AWIF software development team. One of the projects that we're looking at is helping out with West 2 and getting that integrated into AWIF. So, of course, this is very interesting to me. How the two differ and how they can complement each other. One question I have is about scalability. What kind of limiting factors do you see in expanding the use of Wave here in terms of both hardware and communications? Where are the bottlenecks going to be?
The bottlenecks for scaling Wave, let's say everybody in the weather service pops on it and start using it, it's going to be CPU. It's hard to develop a system like this, like a cloud-based architecture. I wanted it to be very fast, and that was my #1 goal. You see other things that plot things like on Esri Maps or Google Maps, and they're great for what they do, but if you want to look at a lot of frames and a lot of data, I didn't have the option to do that, and that would be a little less intensive on your server. So in terms of scalability, it's really computing power. But the nice thing is it's shared because not everybody's using it at the same time. So right now we have 2 CPUs, and you don't normally see a huge lag with Wave at all. But I know offices are using it all around the country.
So the compression is good enough that there's not much of a comms issue or maybe even a storage issue. Is that correct?
Yeah, so we keep everything in Grib because as far as I know, Grib is the best compression. I could take it out of Grib so things would be faster, but that would also fill up the back end in terms of like hard drive storage. But Grads is able to, read the Grib, decompress the Grib, and make the images, and then compress it into pings pretty quickly.
All right, thanks.
We just put some numbers together for the AOP group, but if we had a 30 terabyte drive, we could get several years of data on just 30 terabytes of space. So the way we managed, or I said it's Travis's brainstorming, but we all decide together how we manage the data, and something, for example, for data to her is really huge. So we will filter out some of the fields that we don't think are real necessary, and then we save every hour for like the first, I'd say, a week or so, but eventually we will get rid of and only save every third hour, so it saves up space. So we're filtering and removing some data here and there, but it's still very useful. But as far as storage and how cheap storage is, 30 terabytes for Wave would be a dream for us. What do we got right now, Travis? Like 4 or is it 3?
Yeah, something like that. 4 or 2 terabytes, something pretty small.
Yeah.
All right, yeah, that's one of the biggest problems with Wes is just the incredible amount of storage space it needs just for one case. So,
yeah, we can get years of data on just 30 terabytes. So, yeah.
Yeah, and if we kept everything, we could probably only get, a few days to a few weeks, but we don't keep anything. We're selective about what we keep, and that's I guess what the main difference is right there.
We got a question from Dave Miller of MDL. Go ahead, Dave.
Yeah, hi guys, and Travis, you and I have emailed a little bit back and forth. I'm one of the primary GIS web mapping folks here, primarily for NDFD, but I have my hooks in a lot of different areas as well. One thing I was interested in, since you were talking about one place that this is being hosted, how about portability? I mean, this would, if this was more portable and adaptable to other places who were using their own servers, that would take a lot of bandwidth off of just this one area. And also, along with that, how about I know that it's just you, Travis, doing the development. Is that correct?
Yeah, it's mainly me. Bill's been helping out with the data management on the back end, but right now, it is pretty much me.
So one thing that you might possibly consider here, and that in what's been used in the larger community out there, is an open source type of project using Git or GitHub. That's very popular right now. That's how a lot of the open source stuff is in the community. You just open it up to other folks who work on different aspects of it. They branch it off and propose changes for the main trunk once they've finished their modifications. So that way it isn't just you.
Right, and that's an excellent idea. That's something we need to get to and need to get done. And I like the whole portability thing. It's fairly, it's pretty lightweight. All Wave in its entirety.
Well, can I ask then? I did look at your source code. Is it adaptable to for other places, or are there configuration files? I wasn't sure that the HTML and code was built on the fly, or whether it was just files.
Right. There is a configuration file on the back end. It's probably not perfect, but let's say I had to move Wave to a different server, I could probably set it up in a matter of hours and making that perfect. And so I just click a button and it goes over. That's totally possible too. I just haven't done that level of programming yet. And Wave was never supposed to get this big. It was just kind of a fun side project. Bill wanted an archive for Sacramento of basic fields. And so
Sure.
if I had to reprogram it today, I think I would program it much differently.
Yeah, I understand that. I've been there, done that.
I think you're going to be regional director in a month or so, Travis.
You wouldn't have any of the fun stuff anymore.
We gotta cut off here, but we got one question, quick one, Woody Roberts. Can you do vertical cross sections for models?
No, not right now. That would be possible though.
Okay.
We used to have soundings in there, but I had to take them out. They'll come back in eventually.
All right, very good. EFC says I think we've maybe set a new record here for attendees. We're probably we got like over 30 online, and there's about 20 in the room here. So you guys, obviously, it's a very popular topic, great stuff. I want to thank Travis and Bill for wonderful work and the great presentation. Reminding everyone that this will be, it's been recorded, and John will upload it to the VLab forum website so you can share it with your colleagues who weren't able to attend. Coming up in March, VLab update presented by yours truly. What's happening with the VLab? What's on the horizon? And then in May, we have another very important topic, Prob Severe. For those of you who were at last week's AOP meeting, Michael Pavlonis will be presenting that. That's something to use for facets. It's a high-resolution guidance for severe and tornadic storms, I believe. And there's a lot of talk about using that and getting that into operations as well. So with that, signing off, everyone, and we will see you in March.